K nearest neighbors, or
Yeah.
KNN. It's
Yeah.
famously categorized as a lazy learning algorithm. That word lazy, it sounds almost negative, but it actually describes a really radical philosophical difference, doesn't it? What does it mean for KNN to be lazy?
Yeah, the term lazy is purely technical here, and it's absolutely crucial for understanding the algorithm. You see, most classification algorithms are what we call eager learners. They take the training data and they immediately build an explicit model like a decision tree, or they figure out a hyperplane or a set of weights before they ever see a single test point. KNN does. Well, it does basically no explicit model training whatsoever. It literally just waits until a new test record comes along to do all its heavy lifting, all the computation.
Okay, so if it's not building some mathematical structure, if it's not fitting weights or defining parameters ahead of time, what is the model then? How does it know what to do?
That's the key insight, and this is where the philosophy just completely diverges. The model, quote unquote, is the entire training data set itself. It's just stored. Classification is then based entirely on calculating similarity on the fly, right when it's needed, to its neighbors. It's also categorized as a non-parametric learning algorithm. What that means is its complexity isn't fixed by some set number of parameters. It adapts completely to the size and the shape of the data. And this adaptability, well, it's strength, but also, as we'll definitely get into, its biggest weakness when it comes to resources.
Right. So to make this system work, given that it's not really learning weights or anything beforehand, it relies entirely on this idea of similarity. What are the three foundational things KNN absolutely needs to classify anything?
Okay, three essentials. First, you absolutely must have the full set of stored records. That's the training data itself, just sitting there. Second, you need a predetermined distance metric. You have to decide how you're going to measure similarity or closeness between any two records. And third, you have to pick the value of Tollebrock. That little letter K specifies exactly how many of the nearest neighbors you're going to look at to make the final decision.
Got it. So an unknown record comes in. Walk us through the mechanics then. How does this lazy approach actually spit out a classification?